Hey everyone, and welcome. We are about to tackle one of the buzziest and frankly most confusing topics in all of tech, machine learning. We're going to demystify it together. Let's jump right in.
I mean, how brilliant is that? This quote just perfectly nails the hype and the head-scratching that goes on with ML. It feels like it's everywhere, but getting a straight answer on what it actually is, that's another story.
And you've probably seen this yourself, right? You go to look it up and you find one of two things. On one side, you get these terrifyingly dense academic papers full of math that makes your eyes glaze over. And on the other, you get these super vague articles about the magic of AI that don't really tell you anything, leaving the rest of us stuck in the middle.
Well, that's exactly what we're going to fix today. Think of this explainer as your map, a clear, practical guide to the world of machine learning that cuts right through all that noise and jargon.
So here's our itinerary. We're going to take a tour with 4 main stops. First, we'll get our bearings on the map. Then we'll explore the 3 huge territories of machine learning: supervised, unsupervised, and reinforcement learning.
Okay, first things first. Before we can explore any of these new lands, we need to understand where we are. Where does machine learning actually fit into the bigger picture of technology? This diagram makes it so clear. Artificial intelligence, or AI, that's the big giant circle. It's the whole idea of making machines that are smart. Now, machine learning is a part of AI. It's a specific way to achieve AI by having machines learn from data. And then things you hear about like neural nets, that's an even more specific tool inside of machine learning. So, all machine learning is AI, but not all AI is machine learning.
All right, with our map in hand, let's head to our first destination. This is the most common, most widely used type of machine learning out there. It's called supervised learning. And honestly, the best way to think about it is right in the name. It's like the machine has a teacher.
So here's the secret sauce. The machine gets fed a whole bunch of data that already has the correct answers. We give it thousands of pictures of cats that are all neatly labeled cat. It gets to study all these correct examples, just like you would with a textbook that has the answer key in the back. Now, within this world of learning with a teacher, the machine really has 2 main jobs it can do. The first one is called classification, and its goal is super simple. Look at a new piece of data and decide which category or bucket it belongs in.
Think about it just like this. You show the machine tons of examples of apples and tons of examples of pears. It starts to learn the features, the color, the shape, the size. After a while, it gets so good it can basically draw a line between the 2 groups. So next time you show it a new piece of fruit, it just checks which side of the line is it on. Is it an apple or is it a pear? And you might not even realize it, but you use this every single day. Your email automatically filtering out spam? That's classification. Your bank sending you an alert for a weird transaction? Yep, that's classification too. It's all about putting things in the right box.
Okay, so what's the other big job? It's called regression. And if classification is about predicting a category, like apple or pear, regression is all about predicting a specific number. Not, is it going to be hot or cold, but what's the temperature going to be? 72 degrees? 85?
So how does it pull that off? Well, the machine looks at a bunch of data points, like the ones you see here showing traffic at different times of day. And it tries to draw a line that best fits that data, that cuts right through the middle of all those points. Once it has that line, it can make a prediction for any time of day, even if it's never seen that exact time before. So, we've seen what happens when the machine has a teacher and an answer key. But what if it doesn't? What if it's left all alone with a mountain of data? Well, that brings us to our next stop on the map, unsupervised learning. This slide really lays out the difference perfectly. With supervised learning, we give it all the answers up front. This is a cat, this is a dog. But with unsupervised learning, we just dump a giant messy pile of photos on its virtual desk and say, figure it out. It has to find the patterns all by itself.
The main task here is called clustering. And this sock analogy is perfect. Imagine you've got a laundry basket full of mismatched socks. You don't need a guide to tell you which ones are blue or which ones are black. You just start making piles of the ones that look similar. That is exactly what a clustering algorithm does.
I mean, just look at this. You can see the groups instantly, right? Our brains are wired for this. An unsupervised algorithm learns to do the same thing. It looks at the features of each picture and figures out that the burgers belong together, the pizzas belong together, and the beers belong together, all without anyone ever telling it what a burger is.
So how on earth does a computer actually do that? Well, a really famous algorithm for this has a fantastic analogy. Imagine you want to open some kebab kiosks in a city. First, you just plop them down in random spots. Then, you watch and see which customers go to which kiosk.
Step 3, you move each kiosk to be in the center of its own little group of customers. Then you just repeat that process. Watch, move, until the kiosks stop moving. And boom, you found the perfect centers for your customer clusters.
All right, for our final stop, we're heading into the most futuristic feeling part of our map, reinforcement learning. Now, this is a totally different beast. Here, the machine isn't learning from some spreadsheet of data. It's learning by actually doing things in the real world.
And this is the core idea right here. It's a feedback loop. The machine, which we call an agent, tries something. It takes an action. The world, or the environment, then gives it feedback, either a reward for doing something good or a punishment for doing something bad. Based on that feedback, the agent updates its strategy and tries again. It's a constant cycle of trial and error.
Now, this is a really important distinction. The goal here isn't to get one single answer correct. The goal is to come up with a long-term strategy that gets the biggest possible reward over time. Think about an AI learning to play a video game. It doesn't care about one move. It cares about getting the highest score at the very end.
This little diagram shows it perfectly. The AI learns that going from home to work gets it a positive reward, but maybe going to the bar gets it a negative one. Over thousands, even millions of attempts, it just naturally learns to pick the paths that add up to the highest score. This is exactly how AI mastered incredibly complex games like Go.
And just like that, our tour is complete. We've journeyed across the entire map of machine learning. We've seen how supervised learning is like a student with an answer key, how unsupervised learning is like sorting socks and finding patterns on its own, and how reinforcement learning is all about learning from trial and error.
So we've got the map. We understand the different territories. But as these systems get more and more powerful, it leaves us with a really big and, frankly, very important question to think about. When we're the ones designing that reward, what values are we actually teaching these machines? And what happens if we get it wrong?